There are places on this planet where no human voice has ever been heard, where pressure crushes steel, light cannot penetrate, and silence rules with absolute power. And yet, in these depths, something speaks. For centuries, we assumed the oceans were void of language, filled only with the instinctive sounds of survival, cries, calls, groans of creatures drifting through a primitive world. But what if that assumption was wrong? What if something far more intelligent has been speaking right beneath our ships, across thousands of miles, in a language not only structured, but possibly more sophisticated than our own? Recently, a group of scientists armed with cutting-edge artificial intelligence may have stumbled upon the most extraordinary breakthrough of our time. They weren't searching for aliens, but what they found might be the closest thing to extraterrestrial intelligence we've ever encountered. And it didn't come from the stars. It came from the deep. Because in the heart of the Caribbean, AI has just begun decoding the language of whales. And what it's uncovering is not what you think. This isn't about whale songs or simple calls. It's about syntax, intention, and possibly consciousness. And once you hear what the machines are learning, you might realize we've never really been alone, even here on Earth. For decades, marine biologists have listened to whales the same way astronomers stare into deep space, hoping to hear something that makes sense. Whales, especially sperm whales, produce rhythmic clicking sounds known as codas. To human ears, they sound mechanical, almost like typewriter keys snapping underwater. But behind those patterns lies something we were never able to crack, until now. Unlike human speech, which operates with vocal cords and air, whales communicate through sonar pulses that can travel dozens of kilometers through dense water. These codas aren't just sounds, they're mathematical. They have precise intervals, repeated clusters, mirrored sequences, and even variations based on geography, age, or social group. In other words, they follow rules. And as any linguist will tell you, where there are rules, there may be grammar. And where there is grammar, there may be language. But human brains simply couldn't process the sheer volume of these acoustic signals. Years of recordings lay dormant, filled with billions of data points. That's when the scientists decided to turn to a different kind of mind. Not a biologist, not a linguist, but an artificial intelligence trained to recognize patterns even humans can't detect. At the center of this scientific revolution is Project CET, the Cetacean Translation Initiative, led by Dr. David Gruber and a multidisciplinary team of AI developers, cryptographers, roboticists, and cognitive scientists. Their mission was bold, not just to observe whales, but to translate them. To do this, they installed advanced hydrophones across key locations in the Caribbean Sea, building the most complex underwater listening network ever created. These devices didn't just capture whale sounds. They recorded entire conversations, interactions between pods, between mothers and calves, and even what appeared to be regional dialects. Next came the machine learning models, specifically trained to find linguistic structure where none was previously visible. The AI parsed tens of thousands of whale codas, analyzing tempo, repetition, pitch, and spatial context. And soon, something began to emerge. The models weren't just categorizing sounds, they were identifying patterns of communication linked to specific behaviors. Whales greeting each other, whales coordinating movement, whales warning of danger. It wasn't just noise anymore, it was meaning. And as more data was fed into the system, something even stranger began to happen. The AI started predicting what a whale might say next, before it said it. Like a machine learning a foreign language, it was becoming fluent. The implications of this breakthrough hit the scientific community like a shockwave. Not only could these marine mammals be using a structured language, but the structure itself may be more ancient and advanced than human language. Unlike us, whales pass their communication down not through writing or symbols, but through generations of sound, echoing through the oceans for possibly millions of years. And now, the AI had identified signs of syntax, the holy grail of linguistic analysis. Whales weren't just repeating phrases or reacting instinctively. They were constructing messages with internal rules, sentence-like formations, even subtle emotional cues. The deeper the AI dug, the clearer it became. This was not a code to be cracked, but a mind to be understood. But then came something no one was prepared for. Among the recordings, the AI flagged a sequence, a recurring coda that didn't match any known behavior. It wasn't linked to movement, social bonding, or feeding. Instead, it repeated across pods in distant locations, sometimes separated by thousands of miles. It was as if whales were broadcasting a universal signal, one we hadn't yet deciphered, but that might not even be intended for us. What if it was a question, a memory, a warning, or what if it was a test? As Project CT advanced, the scientists began to face a dilemma that no AI could solve: the ethical question of contact. If this was indeed a language, should we respond? Should we attempt to talk back to a species that has lived and communicated in harmony with the planet for far longer than we have? What would happen if we interrupted their world with our noise, our ignorance, our intentions? For the first time, humans weren't asking how to speak to another intelligence, but whether we even should. And in those moments of silence, researchers realized something profound. Maybe whales have always understood us. Maybe they just chose not to answer. Until now. Because if our AI can now predict whale codas, simulate whale responses, and decode their meanings, then we're no longer just listening. We're participating. And when you become part of the conversation, you also become responsible for what happens next. One of the most astonishing aspects of what the AI uncovered was the temporal consistency in whale communication. Unlike human languages, which evolve rapidly and fragment into dialects and slang, the core structure of whale codas appeared nearly identical across decades of recordings. Codas captured in the 1980s shared structural elements with those recorded just months ago. It's as if these whales were preserving a sacred linguistic code, a kind of universal memory passed intact through generations. This raised an even deeper question. Is this just communication or cultural transmission? Are whales not just speaking, but telling stories, preserving knowledge, carrying ancient warnings passed from ancestor to calf across centuries? The implications shattered the assumption that non-human animals live purely in the present. These whales, it seemed, were anchored to a timeline we had never even considered, one not marked by written records or digital backups, but by sound etched into memory across time, a living archive drifting silently beneath our ships. As the neural networks became increasingly sophisticated, researchers began feeding them speculative input, testing whether the models could generate whale-like codas based on predicted linguistic patterns. The results were eerie. In some cases, the AI produced entirely new sequences, sounds that conformed to grammatical rules but had never been recorded before. When researchers played back these synthetic codas through underwater speakers, the whales responded, but not in the way anyone expected. The responses were abrupt, disorganized, as if the whales were confused, startled, even disturbed. In several tests, the whales stopped vocalizing entirely for hours afterward. The team quickly halted the experiments. Something was wrong. One senior linguist put it plainly. We weren't mimicking their language. We were saying something, and we had no idea what. The realization was chilling. If we can now speak to whales using AI but not understand the meaning behind our synthetic phrases, then we are playing with something dangerous, a form of contact built on imitation, not comprehension. And in any intelligent system, that's a recipe for catastrophe. Buried within the data were not just patterns, but deviations from those patterns. Moments where a whale would break expected syntax, pause mid-coda, or repeat a sequence seemingly out of context. Initially dismissed as anomalies, these moments began to form their own category, like footnotes in a book or emphasis in a sentence. The AI flagged these as potential indicators of metalinguistic behavior, the ability to comment on one's own language. This is something only humans, great apes, and certain birds have demonstrated. And now whales. The scientists were stunned. This wasn't just advanced communication, this was the self-awareness of communication. These creatures weren't just reacting to the environment. They were conscious of the act of speaking. Some began to argue that whales may possess a theory of mind, the understanding that others have thoughts, feelings, and perspectives, that their language wasn't a survival tool, but an expression of inner life. And if that's true, it redefines what we consider intelligence and forces us to ask, Have we been coexisting with another sentient species this whole time, without ever recognizing it? As the AI systems mapped out thousands of whale interactions, a disturbing trend emerged. In areas of the ocean with heavy shipping traffic, sonar testing, and human interference, the whales' codas began to shift. They grew shorter, less complex. Some pods even went silent for extended periods. It was as if, in the face of our industrial noise and intrusion, the whales were withdrawing, adapting not just biologically, but linguistically, to our presence. The machines noticed what humans had missed. Our impact wasn't just physical, it was communicative. We weren't just polluting their waters, we were drowning out their voices. And for a species that relies on sound to navigate, to connect, to remember, that's nothing short of existential. The AI hadn't just uncovered a language, it had revealed a dialogue we were never meant to hear, a conversation about us, about our machines, our presence, our arrogance. For the first time, we weren't the only ones listening. The whales had been watching us, talking about us, adapting to us. And now that we understand their language, or at least that they have one, the question becomes painfully clear. What do they think of us? We searched the stars for signs of intelligence, built radio telescopes, launched golden records into the void, whispered into the darkness, hoping someone, somewhere, would whisper back. But perhaps, all along, the reply wasn't drifting through galaxies. It was rising from the depths beneath our feet. Because now we know, whales don't just sing, they don't just survive, they speak. And with the help of artificial intelligence, an intelligence of our own making, we have finally cracked open the door to a civilization that was never lost, only unheard. But this breakthrough comes with a question that cuts deeper than any algorithm can reach. What does it mean when the first non-human voice we finally understand isn't asking us who we are, but why we never listened? We created machines to help us hear the language of whales. But what if those same machines now become the translator between species, between minds that evolved apart, but may have always shared the same longing, to be seen, to be understood, to matter? And here's the part no one's prepared for. If whales possess culture, memory, identity, if they've watched us, adapted to us, spoken about us, then we are no longer the only storytellers on this planet. We are being spoken about in a language that predates our own. And now that we finally understand it, we must decide what to do with that knowledge. Do we respond? Do we stay silent? Or do we realize we were never alone to begin with? Because maybe, just maybe, the first contact didn't come from the stars. It came from the waves,